Ladies and gentlemen, the mic. What a star performer. The microphone grabs sound. Grabbing sound? Not an easy job. But for the mic, it's a cinch. It grabs sound to turn it into electricity. Only then can sound be amplified so everyone can hear it loud and clear. But how can it capture something as elusive as sound? How can it turn sound waves into electricity using magnets and wire? The mic's performance is all about electromagnetism, what goes on inside the ball and handle. The classic mic sports a sturdy metal casing. The grill is pretty straightforward. It protects the inner parts. Inside the protective metal grill is the pop screen, a piece of foam that screens out wind noises and tames the pops, the explosive sounds consonants like B's or P's make when they hit the mic. At the core of the mic's ball is a capsule, home to the moving coil and a magnetic field. The position of the holes in the cover determine the mic's directionality, the pickup zone where the mic grabs the sound. The mic is a cardioid. It picks up sound coming at it only from the heart-shaped zone directly in front of it. Any noise outside the zone is greatly reduced. The heart shape is what gives the cardioid its name. Once the cover is off, the real show begins. A thin plastic diaphragm is attached to a copper coil. At the bottom of the mic's capsule is a permanent magnet that creates a magnetic field. It's this magnetic field that lets the mic transform sound waves into electric current. Wires attached to the coil then relay this electric current to wires outside the capsule in the mic's handle. And these wires relay the current to an amplifier. Put together, the mic is a clever imitation of the way the human ear picks up sound. Sound travels in waves. As the waves move through the air, they create pressure variations or vibrations, displacing the air around them. When the sound waves reach the ear, they vibrate the eardrum and turn into electrical signals that are sent to the brain for processing. Same deal with the microphone. The dome-shaped thin plastic diaphragm picks up the pressure from incoming sound waves. Its movement matches the exact intensity and frequency of each incoming sound wave. The attached coil moves the same way. It goes back and forth inside the magnetic field, and this movement generates in turn an electric current. The magnetic field created by the permanent magnet is key to the amazing transformation of pure mechanical movement into electric current. According to the laws of electromagnetism, when a wire coil bounces around in a magnetic field, an electric current is automatically induced. So, let's recap. When sound waves hit the diaphragm, the attached coil starts to vibrate inside the magnetic field. And this movement creates an electric signal with exactly the same frequency as the original sound wave. Even with millions of sound waves coming at it, the diaphragm reproduces each and every sound faithfully. The tone depends on how fast the coil vibrates, and that depends on the frequency of the incoming sound waves. A low-frequency sound, like a deep voice, creates slowly oscillating waves. The diaphragm matches the slow speed. The waves of a high-pitched sound create high-speed oscillations, and again, the diaphragm and the coil follow. But the electric current induced in the coil is very weak. It needs to be amplified to be turned into audible sound. Grabbing sound. But there's only one object on Earth that can do this: the microphone. It really deserves a hand. Because without the mic's electromagnetic trick of capturing sound waves and turning them into electric current, all kinds of performances would be oddly silent. There'd be nothing to amplify. In showbiz, the mic is the real performer.